Okay, so in this circuit, we are going to be creating a stoplight sequential JK flip flop circuit. And so, first off, we're going to need to use LEDs for the stoplights and design a sequential circuit for this stoplight. And the first step to that is creating a state diagram. So, this is what it should look like for this specific circuit. We're going to have a green light, yellow light, and red light. And each of them has at least three arrows leading from them. So it means it's going to be three inputs. And so this allows us to see how the stoplight is going to work and how the sequential circuit is going to process the inputs. And then from here, we need to create a next state table, which is going to be this one right here. As you can see, we have three states right here for G, then as well for green, yellow, and red. And this allows us to look at all of our inputs. But before we make the state table, we need to choose what transition table we're going to be using. But in this case, it's going to be a JK flip flop. So this is how the transition table is going to look like right here. And then from here, then you would make a state table. And so you would add the states right here. So 00 is green, and then 01 is yellow, 10, and so on and so forth. And of course, we need the X emergency, the X timing. And then right here is going to be where the transition table is going to help out fill these spots in the state table. And then this is where we're going to use to proceed to the next step, which is going to be to create K maps from this state table. And it will look something like this. Create K maps from the state table that we created, or that's been created. And from there, you need to derive a Boolean equation for each K map. So right here, K1, K1, J1, K1, J0, and then K0. And this helps because from here, the next step is to use these Boolean equations to create and implement a sequential circuit for the problem at stake. So this is what the sequential circuit for this problem would look like. So here we have the LEDs, the output logic gates, we have the emergency and the timer inputs, have the clock, the two JK flip-flops, and of course the next state logic gates right here. And we use tunnels in order to make the circuits look more simple and cleaner. So there's not a lot of wires, making it more confusing and such. And so how this circuit works is that if we were to have both off and the clock is functioning, it's going to stay at the same light. There's going to be no change. But if the timer begins or it's at a high, if the timer is at a high, then the lights are gonna start going, start moving. So it's gonna go from red to green to yellow and so on and so forth. Just keep going in a circle, as you can see right here. As long as the timer is on, it will keep on changing from low to high, from low to high. But if the timer's off and the emergency is at a high, or the timer's at a low and the emergency is at a high, if it's at a green, it's not going to go to a yellow. Instead, it's going to go to red, no matter where it's at. If it's at a yellow or green or wherever, it's going to go straight to red. And when the emergency is at high, and it'll stay there until it's off. And you go again. It's at a yellow, timer's off. You see, boom, goes back straight to red. And so, if you look at the output logic gates right here, you can easily tell that this is a Moore machine, because none of the output logic gates have an input of XE or XT. They're purely a function of the state memory, which makes this a Moore machine. There's also no strobe because it's not a milli, in order to flip flop the outputs that the circuit is giving out. And so another thing is that the JK state tables or next state logics and the next state logic for the T flip flops are a lot or are very much different, due to the fact that if you compare the state tables, you can see that this is the JK flip flop. You can see it has two inputs right here, and it has four required flip flop inputs. And if you were to check out the T flip flop from the previous circuit, you can see it's only one input right here, and it's also including another output right here. This is an output and this is an output, and it only requires two flip flop inputs, T1, T0. And as well as the circuit itself, like I said, T flip flops are more simple. They only require two inputs, T1 and T0. You can also see that from just looking at the transition table as well. And because in T flip flops, you only need like two next state logic gates in order to make the circuit work as it should. And there's also not as much propagation delay, due to the fact that there isn't as much gates and wires that the signals need to travel through as it does for a JK flip flop.